All right. Welcome to another episode of the DSL podcast. I'm your host, Dave Cole. Today we have Paul Turner. Paul Turner is the VP of Industry 4.0 Applications for Stanley Black Decker. Paul, you began your career coming out of college. You got your PhD in manufacturing and analytics from the University of Newcastle, and you spent almost the entirety of your career in manufacturing and analytics. Do I have that right? Anything you want to fill in?
Yeah, that's correct. Always based around manufacturing, but have sort of emphasized different areas. Data science, was a control engineer to start with, but yeah, that's a good summary.
Great. So in today's episode, what we're going to be focusing on is data science and manufacturing. I think we're going to be talking about how data science is being applied in manufacturing. I'm going to learn a lot today. I hope you all do too. And also, I think we're going to touch on sort of the importance of change management, because I think in the world of manufacturing, and we'll talk a bit about the various industrial sort of revolutions that have occurred in manufacturing and what Industry 4.0 is. But I can imagine how data science is being applied, and the getting folks on the factory floor to embrace it, to use it, to understand how to use sort of the results of the models that you and your team are producing. There has to be some challenges there that you've faced. So we'll talk a bit about that as well.
Yep, sounds good.
Great. So first of all, what on earth is Industry 4.0? Enlighten us.
Okay, well, it's the fourth industrial revolution. And if we go back 200 years, just a little bit older than Stanley Black Decker itself, we started off with the first industrial revolution that most people are aware of, which was sort of steam and water powered manufacturing. Mm-hmm. And then the second revolution was mass production around electricity, sort of driving that. The third industrial revolution that people may not have realized was a revolution is sort of the electronics age and computing, and how that sort of revolutionized the way that we start handling data and sort of execute within manufacturing. Mm-hmm. And the fourth industrial revolution, which is this latest one, is really where advanced automation, analytics, and it's about digital transformation. So it's not just about making things digital, it's actually about changing the way that people work by leveraging things like artificial intelligence, machine learning, and a whole host of other advanced technologies that are making how we manufacture different.
And I imagine does IoT, Internet of Things, play into Industry 4.0 as well?
Yes, so we for a while, and probably still are in places, we called it IoT within manufacturing, so industrial IoT. Yeah. But that's what we call the foundational layer from a technology perspective. There are two elements to the foundation for any Industry 4 program. One is just getting the data, and data at the moment sits in many different sources, and you need to sort of bring that together, and IoT is part of the solution for that, to bring the sort of sensor data in from the plant so that you can measure things. And then also there's a foundational layer as far as what we call operational excellence is concerned, and making sure that the basic way that you operate your manufacturing plant is lean and efficient already, because if you apply Industry 4 on a process that's slightly chaotic and maybe not as optimized from a lean perspective, then you're just sort of automating chaos. And so you get the foundations right, and then that's where you really deliver value as you sort of scale up the pyramid of Industry 4 applications.
Got it. So this is basically, so if the third industrial revolution was sort of adding in electronics and computers into the manufacturing floor and sort of improving the assembly line, that was sort of Industry 2.0, so to speak, when electricity came in. Then it seems like 4.0 is all around optimization and using sort of algorithms and models to be able to make the sort of manufacturing line sort of self-healing in a way, or increasing yields through the use of sort of the data that's coming out of the various machines on the floor. Is that, I don't know, is that a decent interpretation of Industry 4.0?
Well, it's certainly a large portion of it.
Okay.
And we often, when we're looking at sort of North Stars, talk about lights out manufacturing, where it's all automated. However, I see that as being quite a way off. What Industry 4 really represents is this sort of cyber physical relationship, this relationship between technology and people, and that's what digital transformation is, and that's why the change management that you said before is so important. And from my perspective, people shouldn't fear Industry 4. It's not about taking away people's jobs and replacing it with robots. It's about upskilling. It's about training. It's about making jobs become careers. It's about sort of improving and empowering people within the factories to actually have more interesting careers, because they're moving from a manual way of working now to a digital way of working.
Right. Like, so there's this great, there should be this great relationship between, the data and the analytics that's coming from that data, and the folks on the manufacturing floor to make more intelligent decisions, right? Yeah. Instead of just sort of finger in the wind, like, this is kind of what I think I should do in this circumstance. So speaking of which, can you maybe take us through some of the problems that you're solving today in this sort of Industry 4.0 mindset? Like if I'm somebody on the factory floor, like what sort of, give me an example of how this is being sort of analytics and data science is helping me.
So there are many examples and use cases of sort of what you could call Industry 4 out there within Stanley Black Decker and of course other industries. Mm-hmm. And so I could go on, I could talk about individual use cases, which I will do. But what I'd like to say first is that what a lot of companies are facing are pilot purgatory, where they've done lots and lots of different pilots, but it's not scaling. And so in order to manage how we approach Industry 4 and different use cases, at Stanley Black & Decker, what we've done is we've developed a sort of a pyramid approach to how we scale the value. And so I've talked about the foundational layer, okay, and which is basically getting the data and getting it in the right format so that you don't have to go to 20 different databases. The next layer is sort of a thin layer of self-service analytics, where we empower people in the plant to actually look at the data and use simple tools to look at relationships. Then what we've done is we've taken different use cases that we've developed. And when I first joined Stanley Black & Decker, we probably had 50, 60. We've got a lot more now. And in order to people to get their heads around it, we've placed them into specific value-driving pillars. Okay, so we have a labor performance pillar, we have a quality performance pillar, we have a safety performance pillar. And there's about 6 or 7 pillars, and different use cases go in each one. And the benefit of that is when you have, like, we could talk about, say, video analytics around quality. Which is heavily using artificial intelligence for identifying defects automatically rather than inspection teams actually going in and manually looking at it. That obviously fits under the quality pillar, and what it does is it focuses people's attention on the value drivers, not the tech. Because one of the challenges of Industry 4 is there are really 3 flavors of it. One is the tech-driven approach, where it's all about the tech. And I went to a major Industry 4 conference, I won't name the one, but they're probably all pretty similar, where it was all about the tech and value wasn't mentioned at all. Okay, and actually operational excellence wasn't mentioned at all. It was all about the tech. So the second,
but by value, do you mean like being able to compute sort of ROI, like So really focusing on, like, hey, if you have a model that's able to detect sort of defects in the product that you're producing, and then you have trained your staff to be able to look at the output and to be able to react to it, you can, over time you will improve, and the cost savings due to, you will be able to lower the number of defects. The cost savings will be like X, over time. It's things like that. Okay. Yeah.
But it's also about managing to strategically align the investments you're making in things like AI and machine learning with the value. Because if you ask somebody, what's your strategy for AI within manufacturing, they may talk about the cognitive computing platform and the architecture. And you could talk for hours and hours about that.
Sure. Yeah.
But then the question is, but once you've got that, how does that relate to value? What are you doing to improve labor efficiency within the factory? What are you doing to improve quality and scrap? What are you doing to improve material flow through the factory? Mm-hmm. Okay, you've got a really nice tool here. There's some amazing innovations that have been done around AI. But that's great, and I want to build a model, but I need to sort of relate it specifically to value. And I've got some, I think I teased you with it on some of our previous discussions around some examples of why getting the balance between the tech, the value, and the domain expertise and the manufacturing knowledge is so important to drive success with science in manufacturing.
We will get there. You mentioned there's sort of three approaches to what companies are taking to this industry 4.0. The first was sort of that tech-driven approach, but with not a lot of focus on the value. What are the other two? Then we'll get to the examples.
The other two is the IT-led approach, where it's seen as your IT initiative, and it's all about platforms and architecture and cloud and IoT, and that's great. However, that's just enablement. Okay, and the challenge with just an IT-led approach is it struggles to see the value. The challenge with the tech-driven approach, of course, is that if you've got a hammer, everything looks like a nail, and you will use technology where probably there are simpler solutions that might be more appropriate. And then the third flavor, which sounds, I guess, the most pragmatic approach, is the lean-led approach, where it's all driven by operations and manufacturing shop floor sort of needs and wants, which is great because from just talking about it. But actually, there are challenges with that approach as well. You're certainly focused on the value. However, there's two things. One is it struggles to scale that approach. You get lots of local innovations, but it isn't looking at it from maybe an enterprise view. And so it's difficult to scale. And then secondly, of course, if you're purely focused on the day-to-day needs of the plant, then you may not know what you don't know. And you may miss that sort of iPhone opportunity that you can get through sort of.
So you're more reactive, right? If you're just reacting to the needs of the floor, right, and you're not, sort of taking a step back and seeing the forest from the trees, so to speak.
And so, ideally, strategically, what you need is a balance of all three of those.
Yeah.
And so that's what we're trying to do within Stanley Black Decker is have this sort of one team approach that involves IT and OT, the sort of the tech side of things, and of course key part is the operations and lean manufacturing.
So OT being operations.
Sorry, jargon. Yeah. IT obviously being information technology, and OT being operational technologies. So things like MES systems, manufacturing and execution systems, automation, PLCs, etc.
Right. Gotcha. Okay. So the right approach is sort of the blend of the three. So maybe talk to us a bit about some of those use cases and how you see sort of the blend of those three showing up in some of the use cases that you've solved. Okay.
So there's another sort of three-legged stool that I need to talk about in order to go into the specific use cases, because I think as far as the parts of the organization and the different flavors of Industry 4, I think provided you have a team where people from the different parts of that team are working together as one, and you've managed to eliminate the barriers and the silos, then you're a team that's really empowered to go and deliver value. Mm-hmm. The second sort of three-legged stool is the balance between data science itself, domain expertise, and a focus on the value that the solution will deliver. Okay, and the reason why this balance is so important is because manufacturing data science is unique, and it's different to, it has many nuances that you may not see in other fields of data science, and that makes it exciting. Okay,
so how is it unique?
So there are, okay, I can give a good example that is counterintuitive. So in manufacturing, I have a use case where a model that is 5% accurate is actually more valuable to operations than a model that is 95% accurate. Okay, now to a data science, that might seem like an anathema. How on earth can a model that's only 5% accurate be in any way better than a model that's 95% accurate? Well, to answer that question, you need the domain expertise. Okay, and this is an example. It's sort of a printing system. And so there's inks feeding the printing system, and they have some quality issues, and maybe they have around 80% yield. This isn't the Stanley Black Decker problem. I'm talking from previous experience. Of that 20% of quality problems, sort of the bulk of that, 95% of that 20% is associated with single sensor issues. So whether it's a flow issue, that one of the inkjets is getting clogged, or whether there's a sort of a low level in one of the inkjets, it's causing a quality issue. However, that quality issue tends to be, you can sell the product still 10% discount maybe. And the key thing is that the operators are already aware of that issue, because there's an alarm in the control system that will go off if there's a flow problem or if there's a level problem. So they already get the alarm. There's nothing operators dislike more, maybe an exaggeration, but there's nothing they dislike more than if they get multiple alarms for the same thing. They have too many alarms as it is.
Yeah.
So what we need is a model that actually fails to predict those 95% of the quality issues that the operator already knows about. But the 5% that they don't know about, they're the ones where the product actually has to be scrapped, and they're the costly ones. Okay, so we want a model that can predict that 5% that has the true value, but also not annoy the operator with these sort of trivial ones that they already know about. And so you can see how you could not put data in front of an AI model and train it without that context.
Right.
And so getting onto the plant floor and living and breathing with operators and the people who are actually going to use the predictions is really important.
Right. So to put it in my words here, so if you have a model that is 95% accurate, but it's predicting stuff that is sort of either that you can sell at a discount, where it's predicting a defect that is not the end of the world. It's just it's a slight problem, but the product is still sellable. Or if it's identifying things that the folks on the manufacturing floor can sort of see with their own two eyes, or just or they have other alarms or alerts that come from the machine itself, without the use of analytics, where they can easily sort of prevent it or deal with it, then it's not that huge of a value add. However, if you have a model that is identifying, say, there's only 5% accurate, but 5% of the time it is identifying defects that you can't normally, like a human, cannot see with their own two eyes. But also it's identifying defects that are sort of so bad that you can't actually sell it in any way. You just need to scrap the whole product. Then that can be incredibly valuable. And obviously you want to increase that 5% as best you can. Because I'm worried about the 95%, that is not identifying. But at any rate, by and large, like that provides a tremendous value to the folks on the floor, because they're like, I had no idea that this defect existed, but thanks to this model, it's helping me, right?
And that's where the value calculation comes in as well.
Right.
What is the utility of this model and how valuable is it? And although that's a specific use case that now maybe seems fairly obvious, there's an important point in that, and it's around that word accuracy, because a lot of data science research is about improving model accuracy, and a lot of companies, startups, and bigger companies that are more mature, when they're trying to present their AI and machine learning and analytics technology, they tend to focus on how accurate it is, and yet actually, it's further down my priority list when I'm looking at how useful a particular tool or analytic will be, because I've got another example where we're looking again at trying to predict quality. We have a model. Actually, before I say that, in manufacturing, quality issues in most cases tend to be quite rare events. Okay. It's not that it's happening every day or on a lot of processes. And when something's a rare event, a model that just predicts that the quality will always be good, okay, is actually quite an accurate model. Okay,
right.
If I've got a 98% yield, okay, and a 2% product quality issue, then I got a model that says everything's going to be great all the time, and it's 98% accurate. Okay, but its utility is zero. Now, of course, we have other statistics for sort of focusing in on how well it's predicting the thing it's supposed to predict. But even that isn't infallible, because there is and this is that financial leg of the stool, there is a value of predicting something correctly and being able to act on it. But there's also a cost of a false alarm. Okay, and that relationship isn't always linear. Okay, and so I've had example projects where the actual optimal model that we've used is a less accurate one, because that balance between the cost of a false alarm and being sent on a wild goose chase or annoying operators, or actually if you're assuming something is faulty and then you have to go in and sort of figure out whether it is faulty, and then you find actually this wasn't faulty, so there's a cost there. That balance and that calculation, and one of the projects we actually did a very detailed calculation to figure out what the optimal model accuracy was, and it wasn't the highest on any of the metrics that you normally use for model accuracy. So again, manufacturing nuances, you need those three legs of the stool: data science, value, and domain expertise.
So what makes sort of manufacturing analytics and data science in one hand, I think I'm like thinking to myself, this is somewhat unique because it's this meld of humans and sort of the output of the models and the analytics, and you need to have this great relationship between the two, which seems to be like the underpinning of Industry 4.0. But on the other hand, I'm like, if models, I think this is, it's not just for sort of the industrial world. I mean, there's plenty of use cases out in the non-manufacturing world where the outputs of a model need to be interpreted, need to be used, need to change behaviors. If you're a bank teller and you're talking to someone and you're trying to pitch them on some new product that you have, you're trying to pick which one to choose from, and some models output like, here's the offer that you should be presenting to the customer. There's some change management there too, right? So it is somewhat transferable, but maybe if you can, is there like a specific, sort of use case or challenge that you've solved, in your career where you felt like that, that model plus that data science plus the humans that interpreting it, worked really well?
Yes, so that's one of the big challenges, and as you say, it's not just manufacturing; it's a challenge more generally. But specifically in manufacturing, factories are busy places, and the whole concept of lean manufacturing is getting things done as efficiently as possible, which tends to mean that people on the shop floor don't tend to have a huge amount of spare time, and so they don't necessarily have time to sit down and analyze in order to act. That they need that done for them. So that's why we talk about predictive analytics and then we talk about insights, but actually the thing that drives value is the action. Right. And if nobody takes any action, doesn't matter how insightful the model is, there is no value. And we have situations where we have sensors monitoring quality, and when they detect that the quality is actually off and it's producing scrap, that there isn't an immediate response from operations, and because they're busy managing and doing other things. So having predictive analytics to predict scrap is great. Okay, but if they're not even acting when the machine's producing scrap,
right.
Are they going to act when the machine's not producing scrap, but a model's telling them that it will produce scrap? Not off the bat, they won't. However, as you say, we need to move to that state where operations is able to act efficiently. And so what we're building within Stanley Black Decker is a platform to do just that. So is to try and actually one of the things we're trying to do is we're using data scientists to actually trying to eliminate the need for a data scientist in that process of predictive analytics. So we're trying to automate as much as we can, right down to the actual prescribed action that operations needs to take. And then once we've got that prescribed action, then actually managing the workflow to ensure that action is taken. And so we think of opportunities within manufacturing as leakages. So if there's an inefficiency in a plant, we call it a leakage because we can put a dollar value on that. And when people can see the dollar value, it's literally like dollars that are leaking away, and this can accumulate, and as it accumulates it becomes more important. And by providing sort of insights and leaderboards around the leakage rates, providing automated workflow around escalations, and giving people metrics around this sort of opportunity handling, that empowers operations teams to prioritize more intelligently and smarter, and work on the areas that the analytics has figured out are actually the high priority areas because they've got the maximum leakage rates and are the biggest opportunity. And so we're trying to combine AI and analytics with workflow automation, and then obviously the people in the loop in order to try and incentivize this process. And we're getting pretty far with that, and we have some great examples where we've automated right up to the point of prescribing action. But if we can't prescribe action, then the action is to go and do what we call a Kaizen event, which is...
What is that?
A Kaizen event is a continuous improvement process or procedure that teams go through in order to troubleshoot and root cause issues on the plant. Okay, but we provide the teams with all the data they need to do that Kaizen process. And we've been very successful with that. But what we're trying to do now is go to the next level and try to automate the Kaizen as well, in order to get to action as quickly as possible, because the driver for us from an Industry 4 team is how do you get from data to action to value as quickly and as efficiently as possible. And technology is something that can help us do that.
So, okay, there's a lot of good stuff in there. So it sounds like what you're working towards is you have a data science team. They've built models to sort of simplify it, sort of to predict, say, a defect or predict an issue, and then what you're trying to do is make sure that not only are you able to, obviously you want to do your best to increase the accuracy for predicting events that cannot be seen by just the trained eye, but are sort of helpful and additive to the folks on the floor. But then not only that, right? You also want to be able to prescribe a specific action to take, right? And then I imagine too, what's important is tracking whether or not the operator actually follow through with that action, or whether or not they didn't. Maybe they were. You said it's a busy place. Maybe it's too busy. They didn't get to it. They missed the alert. They missed it. Or maybe they're stubborn. Maybe they're like, this thing's always wrong. It's always telling me the wrong thing to do. Is that ever a challenge? Like actually getting folks, the operators to not only see the data and even see the prescribed action, but actually to take the prescribed action as well? Is there sort of trust that needs to be built up over time?
So yes, however, we're trying to build this system that will make that a lot easier to sort of drive the action. So think of it as, you've got a pipe in your house and it's leaking. Okay, you can say, yeah, I fixed it. However, there was an algorithm that detected that leak. That algorithm knows that that's leaking, and it can check to see whether it has been fixed. Okay, so when you get to the part of the workflow that says, yeah, we found the root cause, we've taken action, this is what we've done, and we've now fixed it, then you go to a verification phase where the algorithms can check whether it truly has resolve the situation, and then if it has, of course, you can close that event, and you can then be given some sort of recognition for the fact that opportunity has been resolved and it saves so much.
Right, and then attaching the value to it, right? Like you were able to fix this leaky pipe. I have a story from my parents who had a home, and they went away for during the winter, and then actually had a pipe burst due to it froze. It was very cold, and where their home is burst, and it broke, and it caused all sorts of water damage to their house. And if only they had something like an algorithm predicting that this could happen in this event, and they'd act upon it, they would have saved gobs of money, or the insurance company would have anyway. So at any rate, it's close to home there.
is a metaphor for any opportunity. So a leakage could be the fact that for some reason, an assembly line is not sort of producing parts at the speed that the standard said they should, or that another line producing a similar product has managed to set the bar higher, and so there's a gap. We call that a leak. Okay, because is there any reason why we can't learn from this line and sort of drive
efficiency
that way? And so if we can convert leakage into actual tangible financial dollars, it's got to be meaningful. It can't be hypothetical. Then that's what we hope will be a very strong tool in the change management of how operations respond to analytics.
I think this is fascinating, because I think what often data scientists tend to focus on, and I think you're exactly right, is they tend to focus on this great model that they've built, and they tend to focus on the accuracy. They don't always focus, like if your model is not actually changing downstream behavior in a meaningful way, it's worthless. I mean, quite frankly, I mean, it's giving you lots of great predictions, but if things aren't being done about it, then it's really not moving the needle, so to speak. So I think in some ways, I think manufacturing is sort of ahead of the game, because the focus has to be on the value, and has to be on the sort of the change that goes on the factory floor. And so much of this is happening in real time. So much of this is, requires sort of adoption and folks to sort of embrace it. I mean, are there any tips that you think, cross the boundaries, across industries that you would recommend in terms of, that change management problem, or getting, if you can get operators to embrace data science, then hopefully we can get everyone to embrace data science as well.
Yeah. So, I've seen example technologies that sort of nudging behavior, and I'd probably prefer to sort of not comment on that, because there's some ethical aspects of that to consider.
Sure.
Because marketing companies are always looking at a way that they can change people's behavior in the day.
Get me to click on some ad and buy some product. Yeah, sure.
Yeah. So my focus is on people in manufacturing being able to upskill, have more interesting jobs, and be able to see that you're not just a factory worker.
Right.
You are now empowered to actually act and actually have an impact, because we're providing you with the data to support decision making in real time.
And imagine too, you embrace their curiosity. You can say, like, look, if you want to learn more about like how this is happening behind the scenes, like what data we're using in order to increase the velocity of this part that we're making, Like that sort of curiosity, I'm sure you feed into that. I'm sure you're like, absolutely, we'd love for you to learn more, because the more you learn about it, probably the better sort of feedback you get from your folks on the manufacturing floor. And maybe there's a feature that you should be using in your model that they just intuitively know should be part of your model, and you're not, right? And that sort of thing, that sort of feedback can be invaluable. That sort of domain and literally on the floor expertise, right?
It can come in either directions. So if you get sort of a data scientist who may have been, the best in another industry, there's still a big learning curve when they come into manufacturing. You can't just drop people in and expect them to know all these nuances. And similarly, people in the factory who understand the process, they are very, very strongly positioned to be ambassadors for data science and to be able to provide that critical leg of the stool in order to make sure that the data science delivers value. And when I'm actually looking for data scientists, I specifically look for that manufacturing experience. And I often would, because I started off, as a control engineer. I very quickly got into AI and machine learning, but I often look back at the mechanical, electrical, process engineers who were dealing with data all the time, and I still wonder now why more engineers don't start to get into data science. And I know a few are now, but it's still not only are the career options much more wider if you sort of elaborate those skills. They're essential skills in manufacturing to be able to connect the dots between domain expertise and data science. Very, very powerful combination. What we tend to do is we have teams. You have a data scientist, a domain expert, and then somebody who's making sure that all the financials tie up.
Right.
However, if one person can cover two or even possibly three of those roles, then that's very powerful.
Absolutely. I think we talk a lot on the DSL podcast about being able to sort of work collaboratively with sort of the business side, and I think the domain experts and sort of the business side to me are sort of synonymous in a lot of ways. And the more sort of each sides of the aisle, so to speak, understands the other side of the aisle, I think the better off everyone is. Speaking of which, one thing, switching gears a little bit, just focusing on you, Paul. I know in some of our conversations leading up to this podcast, one of the things that I found pretty interesting is just your role today and sort of how it's evolved. I mean, you started off as sort of a control engineer, and then you moved into the world of machine learning and data science and analytics. And now my understanding is you've moved a bit more into like sort of a strategy role as well. And I think one thing we don't talk about in the DSL podcast is like, is there something beyond being a data science leader that you from career wise that you potentially can sort of morph into? Maybe talk a little bit about what your role is today.
Yeah, absolutely. There are career options beyond sort of data science, and so the title Vice President for Industry 4 Apps and Analytics means that I lead a team within the Industry 4 program, and the Industry 4 program covers that foundational layer that I talked about, the connected factory, the apps and analytics that I cover, and then automation, so around robots and cobots. But under that apps and analytics layer, I have several teams. I have a team of data scientists and data engineers. I have an architecture team, that's sort of cloud-based architecture, building the manufacturing analytics platform. And I have a development team and a sort of product/development team. And so we're not. My role is no longer that tactical role of just doing sort of plant-focused use cases.
Yep.
I'm now looking at enterprise scale, and how do I? And that's a challenge in itself, because Stanley Black Decker, for example, has 130 plus factories.
Wow.
Not too dissimilar to lots of companies, and factories tend to be not cookie cutter copies of each other. They tend to be their own islands, and so the one size fits all doesn't really work. However, for enterprise scale, we need standardization in order for it to scale. And so there's always this tension between providing a standard approach and being able to scale it, and yet being able to respond to the individual requirements of each individual plant. And that's also similar to the sort of the tensions between a tactical strategy and the sort of the more longer term strategic. And so one of my roles is to make sure we tie all this together to build a system that is standardized and enterprise grade for analytics within manufacturing, but also doesn't leave the plants feeling alienated because they've got this Uber solution that doesn't really fit their nuances, and building in that flexibility and allowing local innovation, but then having a process and a pathway for taking that local innovation, if it's successful, into a system that allows it to be supported and deployed on an enterprise scale. That's what my sort of day-to-day role is sort of focused on. So that's but you can see the layers that have built up to that.
Yeah, absolutely. I mean, I think there's a whole other podcast with you, Paul, just talking specifically about the nuances of working with manufacturing plants that may, for whatever reason, not be great fits for working with maybe they have antiquated equipment, or maybe they just have their own process. Maybe they're purchased. They were a company that was bought by Stanley Black Decker and just has different equipment, and there could be a whole host of reasons why they may not be great fits for the platform that the enterprise has built. But they still have needs, and they still need to be addressed. And they can't just switch over and use the platform overnight. And I think having somebody who's like yourself, who understands that, gets that, and is able to accommodate their needs and sort of think outside the box, so to speak, I think makes a whole heck of a lot of sense. And you also mentioned sort of a development team. I mean, is some of your role? Is it fair to say that your role today doesn't always involve sort of analytic use cases? Are you also building sort of products for the wider factories as well? Is that sort of how you sort of expanded beyond the DSL, traditional DSL roles and responsibilities?
Yes, so that's why it's apps and analytics. So
yeah, exactly.
It's development, and I actually part of my career I worked with a company that built software products for manufacturing, and so I've done quite a bit of software development, product management as well in my career. And I think that's one of the reasons I ended up in this spot, the data science expertise plus the sort of the software side as well. But they're not independent. A lot of the applications we build have analytics built into them. We have these performance applications that I mentioned earlier around labor quality, etc. If you just look at the asset performance application, that's things like predictive maintenance and energy management and anomaly detection.
Mm-hmm.
The analytics is sort of built in. So these teams work very closely together. And actually, the model we use now is more a multidiscipline team focused on building solutions. So instead of having a development team and an analytics team, we have Scrum teams that have people in them from the architecture group, the development group, and the analytics group, so that they're working as an agile team.
Yeah, I love that. Yeah, absolutely love that. I mean, the focus on the use case, the focus on sort of like that app mindset, and getting them all under the same umbrella, working together as a Scrum team, I think just is great. So, Paul, I think I could probably talk to you for another hour. This has just been absolutely sort of eye-opening for me, just learning about what is Industry 4.0, how the intersection between data science and sort of the change management, and how people use data science to actually take action, the process of sort of tracking that and the workflow, and then how your career has evolved from over time. I think has all just been very fascinating. I think there's a lot of great lessons learned here. I think, while you said before, it'd be great if you had manufacturing experience as a data scientist. I imagine you're also interested in data scientists who are interested in the challenging problems, around manufacturing, right? I think from just what I've heard, putting data science and seeing the actions and seeing measurable results and driving the value, and that to me has just got to be so rewarding, as a data scientist. So I'd be certainly interested in working on your team from my standpoint. So that's great.
It's an incredibly exciting environment to be working in, because it's you see the fruits of your labor.
That's right.
Very, very quickly, and you have great teams to work within, and getting out there into the actual operating environment it makes it very real and very tangible. You can actually
I mean that's a big problem. Getting to ground truth and being able to measure ROI is a big challenge for other industries. But I think in your world, it's very real, and you can get it to relatively quickly, and that is just very, very, very satisfying, right? As a data scientist. So we'll leave it there. Paul, this has been fascinating. I've really enjoyed the time with you. I wish you all the best. And as always, folks out there, if you want to learn more, can they reach out to you over LinkedIn and ping you to learn more from you, Paul?
Yeah, so I'm on LinkedIn. They just look for my name and Stanley Black Decker.
Paul Turner
was an early LinkedIn member, so I've actually got Turner P as my LinkedIn.
Oh, that's impressive. That's very impressive. Well, Paul. Paul, it's been great. Thank you very much for being on the DSL podcast, and have a great rest of your week.
Thanks, Dave.